right, what I would do is on the blank side, I will probably just write addition postulate and subtraction postulate. A postulate is just, it's kind of like a theorem. It's something that you, like theorems you can prove are always true. Like I can prove there's 180 degrees in a triangle. So it's the triangle sum theorem. A postulate is something that's assumed. Sorry if I missed you. All right. So then on the back, you have lines on the back of your card, right? So it's easy to draw straight lines. Great. So you're going to draw a line. And then we need maybe these 2 points right here and here. Okay, so we'll go A, B, C, D. And we'll do the same line on the back of the other card. All right, everybody got the pictures done? Okay, good. All right, so we're going to say in this one that we are given, this is the addition one, that AB is congruent to CD. Josh, what's the symbol above AB? Is it an angle or a segment? Great. Okay. How do we mark that on our pictures? Tick mark. Great. Jason, what does reflexive mean?
The sides are equal. Like
congruent means that something's
like
equal.
AB is congruent to AB.
Very good. So something is congruent to itself. That's the reflexive property, right? Okay. What do we put on the picture for a reflexive property? X. So if you put an X on your diagram, what word should be in your proof? Reflexive. That's it. So ready? Put an X on that. And Jason's right. We're gonna, if we are using an X, it's the same segment on both sides of the congruency symbol. BC is congruent to BC. If you need to, you write reflexive next to this. Okay. Now, we are going to add. If I take AB and add BC to it, that segment starts at A and ends at C. Do you guys agree with that? So, watch what happens. I'm going to put a plus sign here. Notice how the B is the duplicate letter. I cross out the B's. What segment do I have? AC. if I add CD to BC, CD to BC, I just need to pick another color because I can't do it all on top of itself. What letter's duplicated right here? C, I cross it out. What segment do I get? BD. That is the addition postulate. I would use that if AC is a side of a triangle. Does that make sense? And BD is the corresponding side of the triangle. Okay? And once that's in my proof, do I get to use the letter S in my triangle congruency statement? Okay? Let's go to the next one. So that's the end of that card. Okay, so now this one's a little bit different because we're going to do subtraction. So we are going to be given that AC is congruent to BD. In the video, I used highlighters to help people understand and see this. It's also the way when we have overlapping triangles, we can see what's going on. I have AC congruent to BD. But those segments are way too long. In fact, I only need AB and I only need CD. So there's something that they have in common, isn't there? Right? Okay. Jaden, what symbol am I going to put on top of BC? Because it's the same, it belongs to both segments. What did we put on BC up above, on the other one? X. We put an X on there. Okay. Amir, what property goes with the X?
Reflexive.
Reflexive. So we can say that BC is congruent to BC. And the only thing I write with that is reflexive. I don't know why I put an R on the word reflexive. Okay. So now I can do the subtraction postulate. Notice what letter is duplicated. So if I take AC and take away BC, I'm left with AB. And if I take BD and take away BC, I'm left with CD. And now I have a set of congruent sides. Yes?
Does it matter which way the letters go?
Nope. It matters. So it matters that the middle letter is the vertex in an angle. You are not getting a PhD in geometry. If you are given a statement that says AB is congruent to BA or something like that, the reason why they're doing that is because they're telling you what corresponds with what in the two different triangles. We're not going to worry about that corresponding piece at this level of mathematics. It's just like, it's hard enough, the stuff we're doing, right? Yeah. But the thing is, the reason why I taught you guys to line up your letters is because that helps us understand correspondence, right? Okay. So now, those are your two new cards. So, here we go. So it's about reading, marking, planning, writing. All right? Marking the picture. Something we can work on. Okay. So I'm going to teach this like this is the first proof you've ever done. So first of all, how many givens do we have? How many things do we have in the
1,
given?
2, 3, 4.
Okay. Does everybody agree there's 4? Okay. That means we have to mark 4 things. Okay. In your head, y'all need to know what that symbol is. Can you say the word in your head?
Perpendicular.
Oh my God, in your head. Perpendicular. So then above that, you're either going to put right or you're going to put 90 degrees. Either one. Right? Okay, now you're going to go find those 2 lines. So I trace with my finger or my pencil, but I'm not really marking it. C-A-A-B. Oh, it's this angle, which is already marked on the picture. I can't help when pictures are already marked. Okay, good. Let's go find the second thing in the statement. It says ED is perpendicular. Oh, I got another right angle. Go find it. DF. Found it? Okay.
Yeah, Tracy.
Okay. The next statement. Is the next statement about sides? All right, let me say that again. Is the next statement about segments or angles? Segments. Please go mark those segments. So third thing. The third given, mark the segments. You gotta slow down. Okay. So we find the segments C, E, and B, F. How do we mark them congruent? Tick marks. So did everybody do this?
Yes.
So that's, I need you to do it. So it's tick marks. Okay. Is the next one going to be tick marks?
Yes, it will.
Find it, and you would want to use a double tick. That's right. So please find those and mark your tick marks. Are you doing it all in highlighter?
Yeah.
Okay, do pencil.
I don't know.
Okay. You got them on there? AB is congruent to ED. Okay.
Wait, don't we got the flexes?
Okay. So is there a so now we're brainstorming. Is there a possibility that we might put an X on this? Yeah. Yes, right? Is there something that's shared?
Yes.
Okay.
EB.
So I'm going to put an X there. Now, it is a lot. Okay, let's think about, let's pause for a second. Is this the side of a triangle?
No.
No. If I add this to it, do I now have a side of a triangle? Okay, so I need to put addition in. Slow down there, Luca. Take a deep breath. Luca, you got it. Congratulations. Hand down. Okay, great. Is this a side of a triangle?
Yeah.
It's a side, right? This is one of the 3 sides.
Yeah.
And it goes with this side of the triangle. So AB, this could potentially be, or is a side. Now, the only reason why I say potential is because what kind of triangles do we definitely have here? Right. Do you agree? Right triangles?
Yes.
So it could also be a leg. Does everybody agree with that? Okay. Which makes our addition be not a side. What does it make our addition? The hypotenuse. Does everybody agree with that? Because it's across from the right angle. So after we do addition, we have a hypotenuse, which, can everybody see that angle side doesn't work here?
No, because that's the donkey throw.
Yeah, right, it doesn't work.
But we can do HL.
So, yes, we can do HL. So if we're going to do HL, that's a congruent statement and another congruent statement, right? What else? You need 3 things to do the proof. What else do you need to say?
Congruency.
You don't need, before you can say you have congruent triangles, what do we have to say about the triangles themselves? to be able to use,
Reflexive.
no, you can't say reflexive about
Equal.
triangles.
Right.
They're right triangles. So ready? Proofs are either going to be 3 times a congruency symbol, right? Does that make sense? Congruent side, congruent angle. It's going to be 3 of those. Or it's going to be 2 times a congruency and, stop it, and right triangle. Does that make sense? Like it's either side, angle, side, 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 angle, angle, side, right? Those are all congruency statements, right? But if I'm doing H and L, it's 2 congruency and right triangles. Okay, you guys with me so far? Okay. So I know I have a hot disaster up here. 1 is the given, and this is the reason. Now, there are different teachers that do different things. I like to write the given all at once. Do you guys want to separate the given? Like, is having 4 things in the given too much for people?
I think we could do it all in one.
Okay, but you are already okay with this process. I'm not actually talking to you anymore. My other friends.
I think we could do it in one.
You can do it in one. Amir, can you do it in one given statement? All the stuff in one given? No? Want to try separating it and see what that looks like? Okay. So, which one of these, out of the 4 things that are here, this one is a done deal? Do you guys agree with that? We don't have to do anything to that. So let's put that, so statements. We're trying something new. 1. So, AB is congruent to ED based on everything we have planned. Do you guys agree that I can call that a leg? Do you see how I just put the L in the middle? I have one thing done for my proof. Okay. Let's go with the other congruency statement. So the next given is CE is congruent to BF. But CE is not the whole hypotenuse. So what do we need to do right now? The reflexive side, right? So let's do the reflexive side. BE is congruent to BE. So BE is congruent to BE. What's the only word I need to write here to get my points? Reflexive, right? Reflexive. Okay. Now, even though this is a congruency and this is a congruency, neither of these by themselves are the hypotenuse. What do we need to do with this and this? Add them together. That's right. So the 4th statement, the reason why the 4th statement is true is because of the addition postulate. So it's post-you-late postulate. If you wrote addition property, I don't think anyone would argue. Does that make sense? So, I believe that as long as the person grading your paper can still read the things that are there, if you want to draw a line and be like, oh, the E's are going to cancel, that gives me BC, right? What letter's going to cancel here? Ooh, the B's are going to cancel, right? So EF. So now I'm just going to take a pause and look at my picture. Oh, I know I'm hard to scroll everything. Oh, is BC the hypotenuse?
Yeah.
And is FE the hypotenuse?
Yes.
So, what am I going to put right here? The hypotenuse. So, for the 3 things, I now have 1, 2. What's the last thing we need to do, HL? We need to say that our triangles are
Congruent.
no right triangles.
Oh, yeah,
So
right.
before we can do each other, but to have right triangles, we need
Right.
right angles. Did they tell us that did they say that we have right angles, or did they say we have perpendicular lines?
Perpendicular line.
But perpendicular lines make right angles, right? So I'm just going to go here. We have to do the given, though. We didn't put it in yet, did we? But can we do both givens? The last two givens, can we do both givens right now? So that's the only thing about doing givens in parts is you have to make sure all the givens get in your proof. Okay? So the last given was the two perpendicular statements. CAAB, CA, perpendicular to
Why is it
AB.
someone given?
We're trying a slightly different method where,
I don't know what it is.
I kind of have to explain at the end.
Alright.
Okay? Okay, and the other given was EDDF.
I have a question.
Yes.
So if we say about if the perpendicular lines form right angles, do we have to say after that they're right triangles?
So in this type of proof for HL, you have to say you have right triangles.
Okay.
So the first thing we have to, so this is another connection I'm trying to make. If something is over here, right, I need to put it over here. So over here I can put perpendicular lines, and we're going to keep this consistent. Form or make congruent right angles. Please tell me the right angles are like hanging out in space, right? Are they by themselves, hanging out in space? I gotta look at the picture. Oh, angle A and angle D, right? They're hanging out by themselves. So we can say angle A is congruent to angle D. I'm not gonna put an A in here because I don't want it to be an A, right? So now I can say, where's the name of the triangles? A, B, C, D, E, F. Oh, thank God. Triangle A, B, C, and triangle D, E, F are right triangles. How do you, and this goes back to like what you learned in like fourth grade. How do you know a right triangle is a right triangle? What does it have to have?
A perpendicular angle. Right.
Just a right angle, right? How do you know what an acute, like an obtuse triangle is an obtuse triangle? It has to have an obtuse angle, right? Okay, so a right triangle has a right angle. Like if I write the word contains, you don't have to write the word contains. Okay, but now in black, can I go here and put right triangle? So do I have my three necessary things to now write HL at the end? Okay, so, and then I'm going to address your statement of like, why is this proof like a gazillion steps long?
Oh, do you want me to read it out?
No, no.
Okay.
Shh. Let me be the teacher. Triangle ABC is congruent to triangle DEF.
That's actually a good idea. Maybe one day when you're not here.
Okay. Okay, so are you ready
Yeah.
for why this works? Why this is, okay. So, why is this so many steps? Because if you write all the given at once, which I do because I'm lazy, really lazy. Some people get lost in using all the given because you've written all the given down and then you just like, oh, I see vertical and I'm done. No. So this given gave me my first thing. In order to get the H, I needed a different given, the reflexive and the addition. So then, in order to get right triangles, I needed this third given, right angles, right triangles. So could we have eliminated 2 steps out of there? That was as much as we could eliminate, though. Okay, so we can do it a different way on the back. It's just some people want to see it differently. Luca, yes.
So if we put all of the givens together, could we still put the L there?
Yeah, so
I just know just like there's a
So
lot of
this is the deal.
I should know.
this thing is not graded. I'm trying to help you guys understand the process. If that helps you with the process, could you put it there? Sure. So today we're trying some different processes to help get some people that aren't yet on board to try to help them have their aha moment, right? We're trying some ahas. Let's flip the page. I got 10 minutes. Okay, friends, here we go. Let's plan. Okay, they told us we have some triangles. They tell us the very next given says this. Line segment A, B, C, D. They tell us that so we know it's a straight line. That's all it is. Okay? The next thing. Ooh, what does this mean?
Parallel.
Parallel, which means we're going to get some angles out of that. So we're not going to get segments. We're going to get angles. Josh, you with me? Okay. Oh, another parallel symbol. What could we get out of that? Angles. And then this is where I need to check. Are these segments or are they officially sides? So AC. Oh, is AC too long?
That's a segment.
So it's a segment, but can it become a side? What am I going to have to do to make it become a side? Subtract. So I'm going to subtract and get a side. Are there any right angles in this proof?
No.
So automatically we know HL, that's not what I wanted to put there. HL/right triangles are a no. Do we have 2 sets of sides or only 1 set of sides? 1, right? Even though AE looks like it's equal to DF, can I mark those? No, you cannot make assumptions. Okay. So we're probably going to be doing something like angle, angle, side, or angle, side, angle. Okay. Let's do all our givens in one statement. We don't have to write down this part or this part. We have to write down 1, 2, 3. Does that make sense to everybody? So here's our given. We have AE parallel to DF. We have EB parallel to FC. And we have, I'm going to write it underneath to make my life easier, AC congruent to DB. Okay.
Miss Rowe,
Yes?
are you forced to write same information at the top? Or is that optional? Because it's usually write it. Like at the top.
I didn't write it. You should always write it.
Okay.
Yep. Okay. So now I'm going to be like,
I just know.
hey, can I write statement 2 that the triangles are congruent? Can I write it yet? Do I have enough evidence?
No.
No. Okay. So here we go. What do you guys want to work on first? The segments or the angles?
I think we could do the Z's.
Somebody wants to do Z's. Amir, what do you want to do? It's all about Amir today. Amir, what do you want to do? You want to do the segments or the angles?
We'll do angles.
Okay, he wants to do angles.
Yeah.
So I'm not going to do it all at once. Everybody's got a highlighter? I'm going to do the first set of lines that are parallel. Here we go, green. AE is parallel to DF.
These are flashcards for these.
is there a line that connects those two lines?
Yeah.
It's the big long line. Do you guys agree?
Yeah.
Cool.
This one.
Does this, yes?
Can we write arrows on the?
You can, I choose not to because I don't want to make mistakes. Okay. That's why I use colors instead. Okay, great. What kind of angle? So we have a letter that looks like a Z or an N. That means they're what kind of angles? Jerry, can you tell me? Very good, alternate interior angles. Hey, if I put this arc right here, there's only one angle right here. It's angle A. Can I call it angle A? Yeah. What do we got down here? Angle D. Okay, great.
I have the flashcard out.
I'm proud of you.
Do you want me to read it?
No. I'm going to write angle A is congruent to angle D. Because that's kind of what the thing in the middle is. Because if you want something shorter than what I gave you can say parallel lines make congruent alternate interior angles. That's a little bit shorter, and it sounds a little bit more like perpendicular lines form congruent right angles. Does that make sense? Okay. Friends, this is an important thing. I have a congruency statement. Is this set of a congruent sides or congruent angles? Can I put an A here? Okay. Okay. Let's look at the other set of parallel sides. Now, I might want a different color highlighter. Now, I'm going to make this line. This one's harder to see, everyone. EBCF. Is there a line that goes between them? Yeah, just right here. I'm going to make these lines a little bit longer, just maybe, hopefully you can see it. Do I want alternate interior angles here? Are the angles inside the parallel lines? No. Jason, you with me? They're not inside the parallel lines. They are
Corresponding.
no. They are all, you're right, you're wrong. They're alternate exterior angles. Mark them with doubles. Right? Can you all turn your head and see the alternate exterior angles, right? Right? Okay. So, can I call this angle B?
No.
No. Can I call it ABE?
Yes.
So, angle AB is congruent to, okay, I did AB. So, DCF. So, parallel lines make congruent. How am I going to change the words from these previous words? Alternate exterior angles. Okay. Ooh. Do I have another set of angles?
Yeah. Oh, no. Oh, wait, yeah, that's an angle. Sorry, I was looking.
Yep. Can I say the triangles are congruent yet? I have
No.
angle.
No, you need 3.
I need a third thing. Now, right now in my proof, and so this is the problem with highlighters, because highlighters do kind of like make everything crazy on your paper. This is sometimes why I favor colored pencils. So the problem is right now we have, don't just listen for a second. Can you guys finish this up? Do you see how you have BC is too long?
Yes, the subtraction cost.
And DB is too long? Can you do reflexive and subtract? So those of you that are coming to advisement or have AIS with me will finish it in class. Those of you that are not coming, can you please try to finish this proof over the weekend?
Yeah.
You have 1, 2, 3 steps left to go.
Yep, do it.
3 steps. Wait, was that it? Was this the thing you had to fix? Was that right? Finish? Did you guys finish that? All right. So you guys, that worksheet right there is to practice addition and subtraction postulate. Okay, so the note. So you after your quiz, right? Your assignment was to watch lesson 5 notes, right? And so after that, then this is the practice. But you can't see the top half, blah, blah, blah. Okay, where's Amir? Where's Jerry? Is Jerry here?
I feel like no, he was just here last block. And I feel
Oh, he's right there.
Okay, Amir's right here.